Have you ever wondered how Earth's lonely satellite, the Moon, came into existence? Let's sail back in time some 4.5 billion years ago. Picture a young and energetic Earth, minding its own business in the vast cosmos. Suddenly, out of the depths of space, a rogue Mars-sized body named Theia veers into Earth's path. Theia, named after the Titaness mother of the Moon in Greek mythology, is on a collision course. It slams into our young planet with incredible force, sending a storm of debris into the nearby space. This catastrophic event doesn't spell the end for Earth, but instead marks the birth of something new. The ejected debris doesn't simply disappear into the cosmos. Over time, it begins to coalesce, pulled together by the unyielding grip of gravity. Slowly but surely, these fragments come together to form a celestial body we now know as our Moon. So, the Moon, our nightly companion, was born out of a cataclysmic event. Did you know the Moon used to look much bigger to our ancestors? As fascinating as it sounds, it's true. Over billions of years, the Moon has been slowly drifting away from Earth. In fact, it's moving away at a rate of about 1.5 inches per year. This gradual distancing is due to tidal forces, or the gravitational interaction between the Earth and the Moon. As a result, the Moon appears slightly smaller in our sky with each passing generation. You might be wondering, what does this mean for us? Well, as the Moon continues to recede, its gravitational pull on Earth weakens. This affects not only the tides but also the occurrence of lunar and solar eclipses. Imagine a world where solar eclipses are more frequent than lunar ones, where the Moon no longer completely covers the sun. So, in the far future, lunar eclipses might become a thing of the past. Ever wondered what the Moon smells like? It's not a question you hear every day, but it's one that has a fascinating answer. Astronauts who've had the privilege of walking on the Moon brought back an unexpected observation. Lunar dust, they reported, has a scent similar to that of gunpowder. Now that might have you thinking of firework displays or historic battles, but what does it tell us about the Moon itself? This unusual aroma offers clues about the Moon's composition. You see, gunpowder is a mixture of sulfur, charcoal, and potassium nitrate. So the comparison suggests that lunar dust could contain similar elements. But there's a twist. The Moon's surface is mostly composed of small fragments of rock and mineral known as regolith, not exactly the ingredients of your average firecracker. Intriguing, isn't it? So, the Moon doesn't just look mysterious, it smells mysterious too. Do you ever think about what the weather is like on the Moon? Well, let's dive into that, shall we? The Moon, unlike our home planet, doesn't have a substantial atmosphere to buffer the harshness of space. This lack of atmosphere leads to some pretty wild temperature swings. During the lunar day, when the sun's rays beat down, the surface of the Moon can get as hot as a boiling kettle, reaching temperatures of up to 250 degrees Fahrenheit. That's hotter than the surface of Mercury. But when the lunar night falls, oh boy, does it get chilly. The temperature can plummet to a frigid negative 250 degrees Fahrenheit. That's a bone-chilling 500-degree difference between day and night. So the Moon's weather isn't just sunshine and rainbows, it's more like a scorching desert and a frigid tundra. Remember, if you're planning a trip to the Moon, pack for both extreme heat and extreme cold. Have you ever pondered what the craters on the Moon are telling us? Like a history book etched in stone, these lunar craters tell tales of the Moon's past, serving as a chronicle of its many encounters with cosmic bodies. Each impact, each collision, left a mark, an indentation, a crater. They're not just simple holes in the ground, but rather they are records of the Moon's history, providing clues about the early solar system. Think about it. The Moon, unlike Earth, lacks an atmosphere, plate tectonics, or weather that could erase these cosmic scars. So every dent and divot we see has been preserved, like a time capsule. These craters offer invaluable insights into the bombardment that reshaped planetary surfaces, not just on our Moon, but throughout our solar system. They serve as a testament to the celestial ballet of objects whirling and crashing in the vast cosmic arena. Every crater on the Moon is a chapter in the grand history of our solar system. Ever notice that we always see the same face of the Moon? Now that's not because the Moon doesn't turn. It does, but its rotation is synchronized with its orbit around the Earth, a phenomenon known as tidal locking. Here's a simpler way to understand it. Imagine a dance where two partners are spinning but always maintaining eye contact. That's exactly what's happening between the Earth and the Moon. The Moon takes about 27 days to orbit the Earth, and coincidentally, it also takes about the same time to rotate on its own axis. This perfect synchronization means we always see the same side of the Moon from our vantage point on Earth. But don't let that fool you into thinking the Moon is one-dimensional. Just like a coin, it has another side, often referred to as the dark side, even though it gets as much sunlight as the side we see. So while we only see one side, remember there's always another side to our moon. Did you know that the moon is responsible for the tides on Earth? Indeed, our lunar neighbor exerts quite a significant influence on our planet's waters. This all comes down to gravitational pull. The moon's gravity pulls at everything on Earth, but it tugs a bit more on our oceans because of their size and fluid nature. This pulling causes our oceans to bulge outwards in the direction of the moon, creating a high tide. On the opposite side of the Earth, another high tide occurs, due to the Earth's rotation. In between these bulges we get low tides. This gravitational dance between Earth and Moon leads to 2 high tides and 2 low tides each day. Now imagine the ripple effect this has on life on Earth. The tides influence marine ecosystems, affect human navigation, and even generate a form of renewable energy through tidal power. The Moon, distant yet influential, continues to shape life on Earth in its silent, steadfast way,